Okay, so you said that the method of undetermined coefficients is bullshit because there's way too much algebra in there, and you fucking hate that whole guessing bullshit about the fucking extra. Do I times it by x? Do I times it by x? You don't know? Okay, well, I'm gonna tell you what, there's a method that you can use, and you can always use it, unlike the method of undetermined coefficients. You can always use the variation parameters, except sometimes it just may be harder because you got to do some integration. So you may end up kind of getting into a situation where you don't know how to do a certain integral. But other than that, you should. This method will always work out for these equations, higher order equations here. It's just you got to watch out. If you don't, maybe you shouldn't use this method if you have anything above a order 3, because when you're finding the Wronskian, and I'll show you what a Wronskian is in a second, it will turn into a really large determinant. And unless you're good at that, it's really hard to take determinants of functions, at least in my opinion. Nonetheless, let's go. So similarly, you always find, I know it's like this is like so repetitive, right? You always find m squared plus 1 is equal to 0. You can see that, well, yes, you do write it like this. You can't just say, oh, what is it? I need to do it like this. I know, boomer. Plus or minus root of 1, which is equal to 0 plus or minus I, which is equal to alpha plus or minus beta I. And if you don't remember, we are going to use y is equal to c1 e to the alpha x cosine beta x plus c2 e to the alpha x sine beta x. That is the general, oh no, yep, that is the general formula we're going to use to find our nice little complementary solution. We always need to find that. Okay. So, say yc is equal to, okay, c1 e to the alpha x beta x. That's just going to turn into c1 cosine x and plus c2 sine x. That's all it is right there. Okay. And then what you really should do here, because so y1 is cosine x and y2 is sine x. So you don't actually need to do that if you're like really big brain and you just like want to skip steps. You can jump straight to y1 is cosine x sine x. I don't recommend doing it though. Y prime of 1 is negative sine x. Okay, y prime of 2, not y prime of 2, it's y prime 2. Y prime sub 2. Huh. If you say those words wrong, it's actually a big deal. And f of x, well, f of x is the right hand side, which is tangent squared x. Okay, so the formula for this goes y, like our actual solution, is equal to negative y1 u1 plus y2 u2. Okay, so that's our actual answer, but we need to do a few things first. Is we need to find the Wronskian, which is equal to w, yeah, w, y1, y2, y prime 1, y prime 2. Okay, and well that, now we plug in all this crap. Okay, well, see it's cosine x, sine x, negative sine x, and cosine x. Okay, now before I even do this, I haven't done this problem yet. I'm gonna tell you, I bet you it's 1. I bet you the Wronskian's 1. Okay, cosine x times cosine x is how you do it. Cosine x times cosine x is cosine squared x. And remember, sine x times negative sine x is negative sine x, but there's always a negative here because it's this minus, this times this, minus this times this. So this is actually going to be sine squared x, which is equal to 1. Look, I guessed it. Guessed it correct. Okay, so that's w. But u1, what we do is we say u1 is equal to y2, y2 f of x, w, dx. So this is what, and by the way, you can assume your integration constant, balance your integration just to be, you're not going to have an integration constant, so just don't even write it, okay? You're fine. Okay, so y2 sine x, f of x is not cosine squared x, what am I saying? It's tangent squared x. Okay, so we got to figure out a way to rewrite this. Maybe we should try to use a trig property. I'm going to look at my trig sheet real quick. So the trig identity we're going to use is tangent squared x plus 1 is equal to secant squared x. So with that knowledge, we'll rewrite our integral to sine x. Now tangent squared x could be the same thing as secant squared x minus 1 dx. And, well, with this, okay, so sine, maybe we leave sine as it is. Maybe we write this as 1 cosine squared x minus 1 dx, okay. And maybe if we let mu equal cosine x, then we would see that d mu is negative sine x dx. Okay, that might help us rewrite this as, we would see that this becomes 1. I'm not going to write it as 1 under mu, I'm going to write it as, it's negative 2 minus 1. And this will be negative d mu. So what I did is I transferred the negative on there, and then I just swapped it out, because this is dx sine x, and this is sine x dx with the negative, so this becomes negative u. So just a little bit of swapping. Okay, well now we need to evaluate this, not evaluate this, now we still need to find that, which is going to be mu, negative 2 plus 1 is negative 1, minus mu, all this times negative 1, right, because there's a negative here, which becomes 1 over mu plus mu. Okay, that is our answer because the negative 1. No, I should not write that as minus 1. It looks like a minus 1. It's a times negative 1. Okay. So I'm going to erase this identity because I need more space. Okay, now I have more space. So we could write this as 1 plus mu squared over mu. Okay, and mu is equal to what? Well, mu was equal to cosine x. So this is 1 plus cosine squared x, cosine x, which 1 plus cosine x is not equal to sine squared x, because it's 1 plus, it's 1 is equal to cosine squared x plus sine squared x. So we'll just leave it like that. Okay. Let's just hold on to that. Now we need to find u2, which is from y1 f w dx. Which y1 was cosine x, w was 1, f is, where is it? Tangent squared x. Okay. Another thing, another time we got to get rid of this tangent squared x. Now, do we need to? Maybe we could try to do something first. There's a cosine under here, right? Because it's tangent. So we could write this as sine squared x over cosine x. I just got rid, just canceled out one of the cosines under here. Okay, so sine squared x, cosine x. Okay, I'm going to write this sine squared x using the one equals sine squared x plus cosine squared x property. This will be 1 minus cosine squared x. And this cosine squared x is still under it. So I'm going to rewrite this once again. And okay, so I'm going to put this over here, factored in, so it's just going to become secant x, and this will be minus cosine x dx. And you're like, secant x. Well, I hate to say it, just memorize the integral. Okay, and the way I remember, the way I remembered it was that tangent x dx is the same thing as, not the same thing, is ln secant x. So then I could remember the fact that secant x dx is equal to ln secant x plus tangent x. And I just remember this one by heart, and then I think about secant x, and then I remember that secant is kind of a more complicated thing, and if it's more complicated, why don't you just throw in a tangent x, right? So that makes no sense to anyone. I'm sorry, but that's how I remember it. Okay, so let's write this as two integrals. This is equal to, this would be secant x dx minus cosine x dx, which is going to be ln secant x plus tangent x plus, not plus, minus sine x. Okay, and that is equal to u2. So remember yp is equal to negative y1, u1, y2, u2. Okay, so let's recreate yp. Negative y1 would be negative cosine x. Negative cosine x times what? Times u1. Where's u1? This. 1 plus cosine squared x. Cosine x. Okay, well, that goes away. And this is plus y2. This is y2. I mean, y2 is sine x. And this is u2. All of this crap. ln secant x is tangent x minus sine x. Okay, I'm not going to bother to factor this in because I'll do it anyway, whatever. I'll just for you guys. I'm going to distribute the negative. Negative 1 minus cosine squared x plus sine x ln secant x plus tan x minus sine squared x. Okay. Minus cosine squared x minus sine x. What will that become? Well, we can factor out that negative and combine this cosine squared x plus the sine squared x. If we factor out that negative, and we would see that's equal to 1. So, and this would be negative 1 minus 1, which should be negative 2. So we get negative 2 plus sine x ln of secant x plus tangent x. Okay, so that's yp, not just y. Now y, actual solution, right, is yc plus yp. Where is yc? Yc is right here, so it's c1 cosine x plus c2 sine x minus 2 plus sine x ln secant x plus tangent x. Okay, there we go. All of that for all of this. So it's kind of nice. Sometimes it's funny when you get a really small answer after a lot of work, but I guess we get an appropriate answer after all the work. Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up in the algorithm.